Now moving on, this actually is, I think this was most of beginning part of 13, so I'm probably a little out of order. I think we did I's at the end. Can't remember quite, or maybe that was 15. I don't know. We're just kind of, they're all melded together. In a regular Algebra 2 book, this is all in the same chapter, so that's why we're kind of treating it all together. But factoring has nothing to do with I numbers, so this is a complete different, setup of stuff here. So remember this. This is a trinomial. There's a much different ways of factoring. I'm going to solve by factoring here, and we'll kind of talk about the methods of factoring throughout. And this is a classic MA example. Whenever you have a trinomial, x squared x constant, a squared a constant, whatever, MA should work. But in this case, you have a 3 in front. So M turns into 30, 3 times 10, where A is negative 11. Now pause the video and see if you can come up with the numbers that multiply to 30 and add to negative 11. All right, and then I'll get back to you. Kind of a tough one, but not really. It's the common 6 times 5 equals 30. But negative 6 times negative 5 equals positive 30. Negative 6 plus negative 5 equals negative 11. So that's the actual numbers with the signs correct. What you do then is split up the middle term. Again, this is review. We spent quite a bit of time on this chapter. Split up the middle term to match those magic numbers. Now I told my students this minus for sure must be turned into plus and negative before you group, because that's the next set of stuff you have to do. And then you group and then you take out a common factor. So greatest common factor of this is 3a. And then you're left with divide a minus 2. For factoring by grouping to work, the next pull out should give me a minus 2 left here. So that's why I have to pull out a negative 5. And then this is a minus 2. Negative 5a divided by negative 5. 10 divided by negative 5. Then the last thing is pull out this GCF binomial. Now this just says factor, and it doesn't say equal to 0. So this is the answer. That is the factored form. Good FOILers, anyone? Well, in my class, they know good FOILers are good factors. Because good factors, they check their FOIL real quick to make sure that this answer FOILs to be the question, because that's the relationship. A times 3a is 3a squared. Good. Negative 5a and negative 6a. That's negative 11a. And then negative 2 times negative 5, 10. Only the good FOILers know what I just did there. Therefore, they're good factors. Okay, so factor this. This is the only example that I could come up with. I should have done something a little bit better. I made one better for you, that it's a GCF first, then an MA, a basic MA. This one, when you factor, look for a GCF always first, and there is one. 8 goes into both 8 and 72. And then lo and behold, you're left with x squared minus 9. This blew my students away, some of them. Some can do this in a millisecond, some just can't remember this, that this is a difference of 2 squares. X times x, 9 times 9. Good FOILers, good factors. Why is it plus minus? Because x times x, x squared. What happens to the middle term? Positive 3x, negative 3x. Gone. Negative 3 times 3, negative 9. So if that FOILs to be the question, then I'm good to go. But don't forget that the 8's out in front. All right, so that's how you factor that completely. So look out for that. You'll see it's obvious in a multiple choice final exam when a GCF comes out. The questions are pretty blatant on that. And now here we go. What does this say? Y to the what? Y what? And the answer is y cubed. So you'll definitely have one of these on the final where you have to factor a difference of 2 cubes or a sum, one or the other. Remember the formula for difference. SOAP. Whatever this perfect cube is, goes here. Whatever this perfect cube is, it goes here. Binomial. And then SOAP is same. And then the next thing is a trinomial. This squared. Then the middle term is these two multiplied together. Then the last one is b squared. And then SOAP was for the signs. So opposite. So opposite of minus is plus, and then always positive is plus. So I'm going to do sum of 2 cubes right now. Sum of 2 cubes looks almost identical, but the same as what you started with is a sum of these two terms. Opposite of plus, this turns into minus. That's it. That's all you had to memorize. Okay? So, what we have to figure out is, what is the perfect cube of 125? No time, it's 5. 5y. What is the, I know this is a perfect square, but 64 is special. It's a perfect square and a perfect cube. 4 times 4 times 4 equals 64. So here we go. I already got my binomial. Perfect cube of this, same. Perfect cube of this. Next, this is squared. You have to square the 5 as well. So 5y or 25y squared goes here. Opposite. And then what goes here? These two multiplied together. 20y. And then what goes at the end? I cut it off a little bit here, but b squared. So 16. And always positive. Same, opposite, always positive. This is the factored form of this. I swear if you did this, this, and then this, you would get this answer. So this isn't a good foiler, but it is a good multiplier, knows how we get those answers. All right, but we don't have time for that. We got to get this stuff figured out. Okay, then you feel like we're going into something different here. This does kind of stick out a little bit more as a little different thing. This is solved by taking square roots. So if I just have z squared equals, even if I had z squared plus 81 equaled 0, whenever an x squared is by itself, you can solve by just square rooting both sides. But then be careful. In this particular case that I wrote out here for you, this ends up being the square root of a negative. So first things first, it's a plus minus answer whenever you square root both sides. What's the square root of 81, everybody? 9. What's the square root of a negative, everybody? I, which we just covered up there. So this is plus or minus 9i. Next one, even if you have a binomial squared plus number equals whatever, you can go ahead and solve that by isolating the square, square rooting both sides. Now let's break this down real quick in our head. Square root of negative 1, square root of 5, square root of 100. This is 10i root 5. But it's plus minus that. Square root of 100, 10, in case you weren't listening. I like writing I right there. And then root 5 stuck in jail. And then how do you get v by itself? You add 10 to both sides. And you shove it in front of the plus minus 10i root 5. And no, these don't simplify. That is the answer. This is an imaginary solution scenario. Okay, and then we'll talk about that. We have solving. Oh, I have a double square root, so I don't know why I did that twice. Made a little mistake, I guess. Yeah. That's why I ended up with some extra space on my stuff. Whoopsie daisy. All right, sorry for doing that on the movie. Okay. All right, so then let's solve this by completing the square. You might have to know that terminology, what it means to solve by completing the square. So here we go. What you do first is add this 59 to both sides. Now, what number goes here in order for you to make this a perfect square trinomial so that when I'm done factoring, it's going to be z plus or minus a number squared, like a binomial times itself. And it comes from taking half this middle term, so half of negative 8 is negative 4, and then squaring it. That becomes 16. Whatever you do to one side, you do to both sides. So this becomes z minus 4 times z minus 4. You made it happen. You made a perfect square trinomial occur. Okay, boom, 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 boom. That would end up being this. Good FOILers, good factors again. 59, 69, 75 goes here. And I'm going to complete this bad boy or girl off, as far as how complicated this gets. Now we're going to square root both sides. That's why it's right after this last question. And then this becomes z minus 4 equals. This is not an I number. Don't be a robot. It's the square root of a positive. So no I here. 75 is 3 times 25. So square root of 25 is 5. 5 root 3. 3 times 25. All right, plus minus. Then z equals 4 plus or minus 5 root 3, doing it through completing the square.